Welcome to MWN Publications. Today we are publishing the topic Measures of Dispersion. This is after introduction, methods of collection of data, classification, tabulation, then diagrammatic and graphic representation, sampling methods, then measures of central tendency, and then the measures of dispersion. And thank you very much for viewing this. Measures of dispersion. The measures of dispersion is a statistical technique to find out the degree of deviations of data from the central tendency. The measurement of a central value of a data like mean, median, and mode give one single value which represents the entire data, but it fails to give complete description of the data. It does not explain how the variables scatter around central value. Measures of dispersion give a complete picture about the degree of deviation of the data from the central value. This measure is based on the central value. That means the average may be 55, but the lowest value may be in some cases 50, highest value may be 75. In some cases, the average is 55 and the lowest value is 35 and highest value is maybe 95. So this kind of measure is done in this measures of dispersion. Next, let us see some definitions. According to A.L. Bowley, dispersion is a measure of the variation of the items. Then Professor Eller Corner defines as a measure of the extent to which the individual items vary. Then Sprigel states that the degree of which numerical data tend to spread about an average value is called the variation or dispersion of the data. Then W.F.L. Dick defined dispersion or spread is the degree of the scatter of variation of the variables about central value. Then John Giffin defined it as a measure of variation or dispersion, describe the degree of center scattered down by values. It is known from the definitions that the dispersion is a measure of the degree of deviation or scatter of data from the central value. Then objectives are importance of measure of dispersion. Mainly you find that objective is to find out the spread of the data. Then we can let us see what are all that. First one, to find out the reliability of an average. The reliability of data depends on its closeness of its with the central value. Data is more reliable when it is closely related with the central value. And as I told that in the 55 is average, then the highest value is 67 and lowest value may be 49, means it is a reliable data. Whereas the spread is lowest is 30 and highest may be 90 and all, then it is not a reliable one because there is a lot of variation. If the dispersion is of a small value, then the data are more close to a central value. The dispersion is of higher value, then the data are more scattered from the central value. Then second one is to control the variation of data from the central value. It helps to know the cause and nature of variation so as to control the variations. It helps the government to take suitable policies to remove the inequalities in the distribution of income and wealth. The companies can apply this method for policy making and control, because in the average income of India maybe say 50,000 rupees, whereas the spread may be crores and crores, and the lowest level some few amounts only. So that government can take a policy measure to make some kind of equality. Then third one is to compare two or more set of data regarding their variability. It helps to find out the uniformity of two or more set of data with regard to the degree of variation. The D.B.A variation is low. It means the data are with the greatest uniformity, reliability and consistency. Now let us see the different methods of measuring dispersion. There are 5 methods to measure the dispersion. One is range, the another one is quartile deviation, third one is mean deviation, fourth one is standard deviation, and last one is Lorentz curve. Now let us see the first one, that is range. Range is the difference between the largest value and the smallest value of the variables. Hence range equal to largest value minus smallest value, that is L minus S. Coefficient range is L minus S by L plus S. Illustration 1 explains calculation of the range from some data given. So from that range is 90 minus 13, highest value and lowest value, that is 77, and the coefficient of range seems to be 0.75. So merits means it is very easy to calculate. Then demerits, since only 2 values of the variables are taken for calculation, it is not the correct measure for dispersion. And second one is quartile deviation. Quartile deviation is otherwise called as interquartile range. It is the difference between the third quartile and the first quartile divided by 2. In value of 1, that there will be 4 quartile. Here quartile deviation is Q3 minus Q1 by 2, where Q3 is a third quartile, Q4 is a full one, Q1 equal to first quartile. Coefficient of quartile deviation equal to Q3 minus Q1 plus divided by Q3 plus Q1. The values of Q3 and Q1 may also be obtained through the equation Q3 equal to median plus quartile deviation QD and Q1 equal to median minus quartile deviation. The formula for quartile deviation, coefficient of quartile deviation are same for individual observation and discrete series. The quartile deviation for that individual observation given below as n by 1 by 4th item. Q3 is 3 into n by 1 by 4th item. Quartile deviation is equal to Q3 minus Q1 by 2. Coefficient of quartile deviation equal to Q3 minus Q1 by Q3 plus Q1. Always coefficient will give less than 1 value. Thereby on the denominator the plus value and numerator minus value. Now quartile deviation for discrete series. Q3 equal to n plus 1 by 4th item. Q1 equal to 3 into n plus 1 by 4th item. Cumulative frequencies to be calculated, and from that the first and third quartile should be identified. Quartile deviation equal to Q3 minus Q1 by 2. Coefficient of quartile deviation equal to Q3 minus Q1 by Q3 plus Q1. Third one, quartile deviation for discrete continuous series. First of all, cumulative frequencies to be calculated, and from that the first and third quartile class can be known. It can be calculated as follows. After that, Q1 class intervals can be identified as Q1 equal to n plus 4th item. There in the previous case n plus 1 by 4th item. Then first quartile can be calculated as Q1 equal to L plus n divided by 4 minus n by 4 minus F. N by 4 is a common, n minus F divided by F into I. Q3 class intervals Q3 equal to 3n by 4th item, and like that third quartiles can be calculated as L plus 3n minus Cf by F into I. Then the following formula should be applied. That is quartile division equal to Q3 minus Q1 by 2. Coefficient of quartile division is Q3 minus Q1 by Q3 plus Q1. The formula is same for all the cases, for the individual observation, discrete series or continuous series. Now let us see how illustration 2 is calculated. Calculate quartile division from the following data. This is individual observation. Arrangement should be done in ascending order. Thereby n plus 1 by 4th item equal to n plus 1 by 4 equal to second item. That is, there are 7 variables given, thereby 7. That is, the second item is 35. Like that, sixth item, that is 60 to be known, that is Q3. Then quartile division is equal to Q3 minus Q1. Always keep in mind that Q3 minus Q1. That is a formula for all the situation. Here by 2 equal to 60 minus 35 by 2, 25 by 2 equal to 12.5. Then coefficient of quartile division is Q3 minus Q1 by Q3 plus Q1. That calculation will give the value 0.263. That is not much close. It shows, and value should be definitely not exceeding 1. Now let us see about the illustration 3. This is a problem is given to know about the quartile division, coefficient of quartile division for the discrete series. Marks to be calculated and cumulative number of students should be calculated. Only this should be calculated. See, other things are available in the problem itself. So don't get confusion. Some are getting finding it difficult in doing strategies, but it is much easy. And here Q1 equal to n plus 1 by 4th item, 75 plus 1, that is total value 75. 75 plus 1 by 4th item, that is 19th item. 19th item is identified in, that is in the, not in 5, 14, 27. 19 is in 27. First value may be identified. Thereby corresponding to that, the marks being 35. Like that, Q3 is 3 n plus 1 by 4th item, that is giving 57th item. 57 to be identified, not that is 5, see 5, 14, 27, 22, 54. Here 57. 57 is not in 54, it is in the 65. Thereby corresponding to that, the value being 50. That is Q3. Now easily you can calculate. Is it find any difficulty? It's nothing. Then Q3 quartile division, Q3 minus Q1 by 2. Like that, the calculation 7.5. Coefficient of quartile division seems to be 50 minus 35 by 50 plus 30. 15 by 85 equal to 0.176. Not much deviated this shows. Here illustration 4 is given to calculate the quartile deviation for the continuous series. Continuous series means 0 to 1, 10, some series will be there. Then class interval should be there. Frequency is there. So nothing you have to take in the first two column, that X and F, and cumulative frequencies to be calculated in the third. That is very easy because 7 plus 9. First you will take 7. Then just see 9 plus 7, that is 16. Then just see 13 plus 16, that is 29. Then just see 29 plus 11 equal to 40. Then just see 40 plus 6, 46. Then 46 plus 4, 50. It's very easy to know. Here the calculation has been done. Q1 is n by 4th item. Item means total number, n being 50, that is from the cumulative frequency. Last one is the total. 50 by 4 the item, that is 12.5 the item, which is lies in the 10 to 20. 12.5 is in that 10.20. Thereby the value should be in between that only. N cell equal to 10. L means that value corresponding to that. CF means just before that. That is 6. F equal to same to that, 9. I is a difference, that is 10. 0 to 10 and 10 to 20, like that. That difference being 10. Then apply the formula Q1 equal to L plus n by 4 minus F by F into I. 10 plus 12.5 minus F, that is cumulative frequency just before one. No. That value gives you 17.22. Then Q3 equal to 3 by n by 4th item. That is 3 into 50 by 4 equal to 37.5 fifth item, which lies in 30 to 40. Hence L equal to 30, CF 29, F equal to 11, and I equal to 10. Then when applying, that will give the value 37.73. So just to keep in mind, the value should be in between 30 to 40. If it is below 30 or above 40 means your calculation is wrong. Then coefficient, the quartile division can be calculated, Q3 minus Q1 by Q3 plus Q1. Thereby, by applying that 37.73 minus 17.22 by 37.73 plus 17.22 equal to 20.51 by 54.95 equal to 0.37. Now let us see the merits. First one is it is superior to range as a measure of dispersion. It cannot be affected by extreme values. It can be measured for open and end distribution. Demerits, it is not capable of further algebraic analysis. Second one, sampling functions affect much of its value. It is not good measure when the degree of variation is high. Then we have to study about the mean deviation. First one is range, second one is the quartile deviation, third one we are going to find out mean deviation. Mean deviation, by that you can keep in mind arithmetic mean deviation. Thereby it somewhat resembles through the calculation of arithmetic mean. Let us see the meaning. Mean deviation is otherwise called as average deviation, as I told you. It is a measure of deviation based on all the items in a distribution. But in a range and quartile deviation, only two values are taken into consideration. that is in the range lowest value and highest value, the quartile deviation, 3 quartiles are taken into consideration, other numbers have not been taken into consideration. Mean deviation may be defined as the arithmetic average of the series. While calculating of the sum of the equations, deviations, minus should be ignored. That is more important. Minus should be removed. Then, say, everything should be considered as positive. Calculation of mean deviation. Mean deviation is for individual observation. So, 3 kinds: individual observation, discrete series. Discrete series means frequency is there. Continuous series also frequency is there. That mean deviation is equal to sigma modulus d. Modulus d, sigma d indicates sum of deviation from the mean or median or mode. Commonly, deviation from the mean only. Modulus d can be, this can be read as modulus d. N indicates total frequencies. Coefficient of modular deviation means mean deviation by mean or median or mode. If the deviations are calculated from mean, then that denominator should represent with mean, or median means median, mode means mode, only one item. For calculating coefficient of mean deviation, divide mean deviation by, so what here has been given like that. Okay. Now let us see about the mean deviation for discrete series. Mean deviation for discrete series, only f should be added. Sigma f modulus d divided by n. There only sigma d modulus d. F means frequency. Deviation from represent frequency. Deviation from mean or median or mode of variable should be multiplied by respective frequencies. Mean value should be calculated and the difference between the value of the variable and mean, and then each would be of that would be multiplied by the frequency, corresponding frequency. Mean deviation for continuous series, the same formula. Then the deviation of the midpoints or class interval from mean or median or mode should be multiplied by the respective frequencies. Here instead of the value in x, that is there x means only one value may be there. Here in that class interval maybe 10 to 20, 20 to 30 like that. There from each n value you should consider 0 to 10 means 5, then 15, 25 like that, mid value, and from the mid value the average should be divided, should be differentiated, and minus value should not be taken, all values should be considered, and with that frequency should be multiplied. Then illustration 5 is given to calculate the individual observation. Some values are given that is not in ascending order, should be make it as ascending order, lowest to the highest, 15 to 44. Then you are taking that average, first calculate sigma x equal to 210. 210 by the total number means 7. 7 numbers have been given. 210 by 7 equal to 30. That is arithmetic mean. Then in the second column, what you are going to do is x minus x bar. X bar has been calculated as 30. X minus 30. That means 15 minus 30 means minus 15, but minus ignored. Second one, 30 minus 19, that is 11. Next one, 30 minus 26, that is 4. 30 minus 30, 0. 35 minus 30, 5. 40 minus 30, 10. 40 minus 30 is 15. So you can add, then sigma d modulus d is 60. Then it can be easily calculated by applying the formula mean deviation, that is sigma modulus d by n equal to 60 by 7. That is total number is 7. That is equal to 8.75. Then coefficient mean deviation is mean deviation by mean you have taken that x bar, here it has been mistakenly put as median, mean deviation by mean. mean is 30, then thereby 8.57 by 30 means 0.27. That is not also a high spread. The sixth illustration is given. For individual observation, you are expected to calculate that mean, median and mode, and from that you have to calculate the mean deviation. That means for taking mean in one and taking median in another, taking mode for the third one, and for taking the difference. Now let us see how it is calculated. X value you can arrange it according to ascending order, that is 9 to 43, and here there is no frequency because individual observation. Then you are taking the total, that is 175. First calculate mean, median and mode. First of all, here it has been calculated the median first. Here it has been asked to calculate the calculate the mean deviation from mean, median and mode. But here it has been yes. First it has been calculated, the arithmetic mean has been calculated. Sigma x by n, that is total is 175. 7 item, there will be 7 divided by 7 equal to 25 is the x bar. Median equal to n plus 1 by second item, that is 7 plus 1 by 2 equal to fourth item. Fourth item, see that 1, 2, 3, 4, that is in 29. 9, 14, 20, 24. That is fourth item is 29. Then median based on, mean deviation based on mean has been calculated. Sigma, that is sigma modulus d divided by 7 equal to mean deviation based on mean. That is now 9.14. Coefficient of mean deviation is mean deviation divided by median. Mean deviation divided by mean. That is 9.14 you calculated as it is mean deviation. Then median value is 25 equal to 0.37. There in the mean deviation based on mean is 9.14. Then mean deviation based on median is coefficient of mean deviation also calculated. Mean deviation based on median is 8.57. Coefficient of mean deviation is 0.3. Mean deviation mode is equal to 61 by 7. So mode is the most commonly appearing item. So mode is 61. Here it is has been given as mode as mode as 30, because 30 repeated many times, 2 times it is repeated. When other items are repeated only once, thereby 30 can be considered as the mode, most frequent appearing item. There, based on that, you have to calculate the difference, and that sigma difference of that will be taken as 61 by 7, 8.71. Then mean deviation 8.71 by 30. Then I am just telling how it is calculated, because in the second column the difference is based on mean, third column difference is based on median, fourth column difference is based on mode. Mean is 25, median is 29, mode is 30. That first I show you how it is 9 minus 25. 16 minus eliminate, 14 minus 25, 11, 20 minus 20, 25, 5, 29 minus 25, 4, 30 minus 25, 5, 30 minus 25, 5, then 43 minus 25, 18. Like that, median is 29, then calculate the difference. 29, 9 minus 29, 20, 14 minus 29, 15, 20 minus 29, 9, 29 minus 29, 0, 30 minus 29, 1, 30 minus 29, 1, 43 minus 29, 14. Then mode, that is 30. From 30, difference should be known. 9 minus 30, 21. Then 14 minus 30, 16. 29 minus 30, 10. 30 minus 30, 0. Then 30 minus 30, 0. 43 minus 30, 30. Total value should be calculated. That is sigma modulus D based on the mean 64, based on median 60, based on mode for 61. The total of that to be calculated. 16 plus 11 plus 5 plus 4 plus 5 plus 5 plus 18 gives 64. Like that, other calculations should be done. Then illustration 7. Illustration 7 is to calculate the mean deviation based on the arithmetic mean, that is based related to the frequency distribution, that is in discrete series. That means one x means some value variable will be there, frequency, how many times it repeated. Here it is income and number of cases have been given. So first 1, 2, 3, 4, 5, 6 columns table should be prepared. First one is incomes, and second one number of factories as given in the illustration we have to take. Then deviation from assumed mean. So you have to calculate the mean value. So mean value can easily be calculated through assumed value. Then it is better as that indirect method of calculating mean. That is assumed mean of calculating mean. Assumed value. Okay. Then just to see that deviation from assumed mean to be calculated. That is, you have assumed that 550 according to the convenient, and then 550 or 500 you can take. That seems to be somewhat about mid value. If you are taking 600, that is also good, not nice. You can take 650 also. The answer will be same, but for convenience sake, it should be taken some middle value. Then you see that 400 minus, that is middle value, you have taken 550. Then 400 minus 550 is minus 150. Yes, you have to take the minus value. You are going to not calculate the modulus D. Only small d you are going to calculate. That being, yes, thereby 550, 400 minus 550, 450 minus 550 is 100. 500 minus 550 is minus 50. Yes, 550 minus 550 is 0. 600 minus 550, that is plus value 50. 650 minus 550 is 100 plus value. Then FD to be calculated. In this value, you have to multiply with frequency. That means 5 into minus 150, that is minus 750. 7 into minus 100, minus 700. 12 into minus 50, minus 600. 17 into 0, 0. 6 into 50, 300. 3 into 100, 300. Now calculate the difference, modulus D. So here this much calculation to be done, but in the previous case only from the mean directly you can calculate. The mean can be easily calculated. Here you have calculated the mean. How you have calculated means x bar equal to assumed mean plus or minus sigma FD by n equal to, here the positive value is 550 assumed. You have assumed as 550 plus the total value is FD value sigma FD minus 1450 into n, means n is given as 50, that is total number of factories, that is 7, 5 plus 7 plus 12 plus 17 plus 6 plus 3, 50. Then that will be giving a value of 550 minus 29. It is 529. One is the arithmetic mean. Then you can apply it in the fifth column, that is x minus x bar. That is x minus 521, 521. So 400 minus 521 modulus D, so minus symbol should be ignored. 400 minus 521, it is minus 121, but you are ignoring that. Then 450 minus 521, 71. 500 minus 521, 21. 550 minus 521, 29. 600 minus 521 is 79. 650 minus 529 is 129. Now from this value you should multiply with the f. F is in the second column. So second column and fifth column value should be multiplied. 5 into 121, 605. 7 into 71, 497. 12 into 21, 252. 17 into 29, 492. 6 into 79, 474. 3 into 129, 387. Then you have to take into the total of that to find out sigma f modulus D. That is 605 plus 4 plus 497 plus 252 plus 493 plus 474 plus 387 equal to 2708. Then you are going to apply modulus D, mean deviation, that is total 2 in the 6th column value is 2708 divided by that n is given in second column, the total of that is 50 equal to 54.16. Then this one give a clear picture, but when we are taking into account of coefficient of mean deviation only, it is assumed mean deviation by mean, that is 54.1 by 16 by 521, that is 0.104. So deviation is much wider, not close to the arithmetic mean. Okay. Now calculation of mean deviation for continuous series. For that illustration 8 has been given. Here two columns x and y are there. X containing the free continuous series, that is the variable 0 to 10, 10, 10 to 20, like that till 72.8. Corresponding frequencies are given in the second column. Then let us see the solution. Here that assumed mean has been taken as 35. Hence 35, and here x 7 column to be prepared, and first two are as like from the illustration, and the third column is mid value, that is 0 to 10. Mid value of 0 to 10 is 5, 10 to 20 is 15, like that you have to calculate for up to 70 to 80. That is 5, 15, 25, 35, 45, 55, 65, 75. The dash to be calculated. D dash means assumed mean m minus assumed mean. Assumed mean has been taken as 35. That mid value minus 35 by 10. That is mid value 5. I mean 5 minus 35. That is means 30 by 10 minus 3. 15 minus 35. 20 by 10 minus 2. 25 minus 35 by 10. That is minus 1. 35 minus 35 0, that thereby 0. 45 minus 35 means 10 by 10 1. 55 minus 35 means 20 by 10, that is 2. 65 minus 35 by 10 is 30 by 10 is 3. Then 75 minus 35 means 40 by 10 4. Then frequency should be multiplied corresponding with that D dash. Here frequency is 3. 3 into 3 minus symbol is here, thereby minus 9. 6 into minus 2 minus 12. 7 into minus 1 minus 7. 11 into 0 0. 9 into 1 9. 7 into 2 14. 5 into 3 15. 2 into 4 8. Then modulus D should be calculated, that is by that m minus 38.6. Here that real arithmetic mean has been calculated, that is x equal to a plus or minus sigma f_d by n into I equal to 35 plus 18 into 10 by 15 into 10 by 50 equal to 35 plus 3.6 equal to 38.6. Modulus D should be definitely the real arithmetic mean difference between the real arithmetic mean and mid value. So real arithmetic mean is 38.6. The calculation is given just below. And the modulus D means there should not be any minus symbol. Here just see that mid value 5. 5 minus 38.6 is 33.6. 15 minus 38.6 means 23.6. 25 minus 35.6 means 13.6. 35 minus 38.6 is 33.6. 40 minus 38.6 means 6.1. 6.4. Then 55 minus 38.6 is 16.4. 65 minus 38.6 is 16.4. Then 70 minus 38.6 is 36.4. Then modulus D should be multiplied with frequencies. So frequency is second column. So 3 into 33.6 is 100.8. 6 into 23.6, 141.6. 7 into 13.6, 95.2. 3.6, 39.6. 9 into 6.4, 57.6. 7 into 16.4, 114.8. 5 into 26.4, 132. And 2 into 36.4, 72.8. Then you have to calculate the total of the F modulus D. That gives value of 754.4. So mean deviation equal to that sigma FD by N, that is 754.4. N is 50, that is you can find from the second column. The total of the frequency seems to be 50. That 50 should be taken. Thereby, the 15.088 would be mean deviation. Then coefficient of mean deviation is mean deviation by mean. Thereby, 15.088 by 38.6 equal to 0.39. Now let us study about the merits of mean deviation. It is easy to calculate. It takes into account all variables of the distribution. It will not be affected by the extreme values. The fluctuations of samples will not affect the calculation of the mean deviation. Demerits: it is not for further statistical analysis. It is a non-algebraic method since the negative signs for the deviations are treated as positive. It is not a popular method. Next one is standard deviation. Standard deviation is the popular and widely used measure of dispersion. It is the square root of the sum of squared deviations from average. Standard deviation has its own merits over other methods of dispersion, since it analyzes the deviations by squaring it. In this method, deviation should be taken only from the arithmetic mean. It is denoted by the small Greek letter sigma. Then calculation of standard deviation for individual observation. Standard deviation is with the small sigma, that is square root of sigma x square by n, or square root of x square by n, where x indicates the deviation from arithmetic mean, that is x minus x bar. This kind of calculation has been done in the previous case also. N is the total number of variables. If the observations are the complicated one or of very large size, then it takes time to find out the arithmetic mean. Further, it will be complicated to find out the deviations if the arithmetic mean is in fractional figures. To overcome these difficulties, shortcut method can be applied to calculate the standard deviation. Formula for standard deviation under shortcut method is sigma equal to sigma d square by n minus sigma d by n the whole square. D refers to deviation taken from assumed mean. In the direct method, the deviation should be taken from the arithmetic mean. If so happen the arithmetic mean is in fractional value, then the difference will also be fraction, square value should be fraction. So in order to avoid that only, this kind of method we are going to adopt. Then calculation of standard deviation for discrete series. Small sigma equal to square root of sigma f square by n. Standard is f is frequencies, x equal to deviation from arithmetic mean, that is x minus x bar. N is the total number of frequencies, otherwise sigma f. If the calculation of arithmetic mean is difficult, then the shortcut method can be applied to calculate the standard deviation. In the shortcut method, assumed mean, that is more important, assumed mean can be used instead of the actual mean. Formula for standard deviation under shortcut methods is equal to square root of sigma fd square f d small d by n minus sigma fd by n the whole square, where d indicates deviation from assumed mean. D equal to x minus a. A is the assumed mean. F is a frequency. N is a total number of frequencies. If the variable got common factor, then the calculation for standard deviation may further be simplified through calculation under step deviation method. Formula for standard deviation under step deviation method is as follows. Step deviation is adopted when that is in multiples of 100 or 5. Here it is sigma fd dash by n minus sigma fd dash by n the whole square into c. That c is that indicates class interval, where d indicates natural deviation from assumed mean divided by a common factor. D dash equal to x minus a by c indicates common factor for the observation. F indicates frequencies. The n equal to total value of the frequencies. Then calculations for standard deviation for continuous series. The formula for standard deviation in the continuous series is almost same to that the formulas for discrete series. In this series, the midpoints of the class interval should be taken into account instead of the variable. Following formula would be used for calculating the value of standard deviation. One direct method, small sigma equal to square root of sigma f square by n, where x is a deviations from arithmetic mean, small x, that is x equal to x minus x bar. F is frequency, n is the total number of frequencies, n equal to sigma f. Shortcut method. In this method, arithmetic instead of arithmetic mean, assumed mean should be taken into consideration. The formula is sigma square root of sigma fd square by n minus sigma fd by n the whole square. You have to keep in mind about the sigma fx by n minus fx by n, and the fx you have to keep in mind. Here where d indicates deviation of midpoints from the assumed mean, and that is d equal to m minus a. Step deviation method. In the step deviation method, that common factor should be taken for division. In this case, formula is small sigma equal to square root of sigma fd dash square by n minus sigma fd dash by n the whole square, and after that into c, where d dash equal to deviation of midpoints from the assumed mean divided by a common factor, that is d dash equal to x minus a by c, c equal to common factor. Step deviation method is the most common method adopted for calculating standard deviation in continuous series. Now let us see about the illustration. Here the illustration has been given to calculate the standard deviation for individual observation. Only variables have been given, that is not in an ascending or descending manner, but we have to make it in the ascending order. 3 columns should be prepared. One x for the variables, and the second one is small x, that is x minus x bar. That is here x bar has been calculated by taking into account of in the sigma x by n equal to 154 by 7 equal to 22, given in the after the table. That 154 is a total of the x, so 22. Now the x minus x bar means x minus 22. Thereby 15 minus 22 is 7 minus 7. that is 17 minus 22 minus 5, 19 minus 22 minus 3, 22 minus 22 0, 24 minus 22 2, 27 minus 22 5, 30 minus 22 8. Then square of it should be calculated. That is in the third column, 7 into 7 49, 5 into 5 25, 3 into 3 9, then 0, 2 into 2 4, 5 into 5 25, 8 into 8 64. Here the total of the total of the a square, small a square should be taken, that is sigma a square equal to 166, total in the third column. Here small sigma equal to sigma a square by n, that is square root of 176 by 7, that gives a value of 5.01. Then let us see the illustration 10, that is also calculation of standard deviation for the individual observation. Here the indirect method is applied, that is assumed mean has been taken into account for the instead of arithmetic mean. Here directly you can calculate, you do not go for the calculation of x bar. Here in the first column x to be taken, in the problem itself it is in the ascending order, thereby the value has been taken, that is variables have been taken as it is. Then small d, that is x minus 39. 39 has been taken as an assumed mean. It may either be 34 or 30, like any number, but it is better to have a middle value of that. Then next to see the x minus 39, that is x minus 8, that is 23 minus 39 minus 16, 30 minus 39 minus 9, 34 minus 39 minus 5, 39 minus 39 0, 45 minus 39 6, 47 minus 39 8, 50 minus 39 11. Then square of it should be calculated, that is d square, that is 16 into 16 256, 9 into 9 81, 5 into 5 25, then 0, then 6 into 6 36, 8 into 8 64, 11 into 11 24. Then in the third column that value should be added, that is sigma d square equal to 583. And directly you can apply this sigma, that is standard deviation. Formula is sigma d square by n minus sigma d by n the whole square equal to 583 by 7. That is 7 is number of variables 7. That is minus 5 by 7 square. That is sigma d. That is sigma d by n. Thereby the calculation has given the value 9.10. Then hereby you can see that it is somewhat varied, that is how far extent it is away from the arithmetic mean, you can find 9.1 level. Now let us see the illustration 11. This illustration is related to the calculation of arithmetic mean for a discrete series. Here you can find the variable and frequencies, the repetition 3 times 75 repeated in 3, 100 repeated in 7, like that it is. Then you have to prepare it in a column 1 2 3 4 3 4 5 6 columns table, and first one and the second one are as it is given in the illustration. First one is sales, second one is frequency. Then here we are going to apply the indirect method, assumed mean method. It has been assumed 150 as the assumed mean, that is integral of that value. Then thereby x minus 150 by the common difference is 25. That because 75, 100, 125, it is like that it is going. In all the cases 25 is a difference. Then only you can take. Some kind of first one 25, second one 20, third one 30, like that difference means this way you could not apply. You can directly apply as x minus 150 itself. Then it is giving the value, that is 75 minus 150 by 25 giving minus 3. Then 100 minus 150 by 25 giving minus 2. Then 125 minus 150 is minus 1. Then 0. Then 175 minus 150 by 25 1. Then 200 minus 150 by 25 2. Then 225 minus 150 by 25 is 3. Then we have to square up that, d square, that is 3 into 3 9, 2 into 2 4, 1 into 1 1, then 0, 1 into 1 1, 2 into 2 4, 3 into 3 9. Then FD dash you should calculate, because it is assumed mean we have to consider. Otherwise we need not take this. That is FD dash. That is D dash is minus 3. So 3 into minus 3 9 minus 9. 7 into minus 2 minus 14. 9 into minus 1 minus 9. Then 0. Then 12 into 1 12. 3 into 2 6. 6 into 3 18. Then you have to find out the total, that is equal to 4. Then in d square into f should be calculated. D square is 9. Then 3 into 9 27. 7 into 4 4. 28. 9 into 1 9. Then 0. Then 12 into 1 12. 3 into 4 12. 6 into 9 54. Then total of it is 142. That should be taken. Then in the assumed mean, it is assumed 150 as a arithmetic. Then small sigma, that is standard deviation, is sigma fd dash square by n minus sigma fd dash by n the whole square. Formula is same. Only f is inducted for that frequency distribution. Otherwise f will not be there. Thereby, by applying that, you will be getting the value of 42. Now let us study about the illustration 12. This is also calculation of standard deviation for a discrete series. In this discrete series, we have applied the arithmetic mean. Previous one, we have applied the assumed mean. Find out the difference, because first you have to find out the arithmetic mean. Then it gives a value of 44. Then since there may not be any fraction and that idea it has been proceeded, then it would be easy. Then the column 1 2 3 4 5 6 columns have been taken. First two columns as it is in the illustration. Third one is you have to f into x. That is in the first sum 17 into 3 51. Like that you have to calculate. And n is equal to 70. Total of the second column. Fx total of the third column. That is 38. Then x minus x4. That you find out here the arithmetic mean, that is 3080 by 70, that is equal to 44. Now you are applying x minus x4, x bar, that is x minus 44. So difference should be taken for the, that is 17 minus 20, 17 minus 44 minus 27, 23 minus 4 minus 21, 35 minus 44 minus 9. 40 minus 44 minus 4, 47 minus 44, 3, 50 minus 44, 6, 53 minus 44, 9, 60 minus 44, 16, 70 minus 44, 26. Then you have to square up that, 27 into 27, then minus 27 into minus 27 will give the positive value. That is 729, 21 into 21, 441. 9 into 9, 81, 4 into 4 is 16, 3 into 3, 9, 6 into 6, 36, 9 into 9, 81, 16 into 16, 256, 26 into 26, 676. Then you have to multiply with f, that value, that is 3 into 7 to 9, that is 1187. That 7 into 441, 3087, 9, 9 into 81, 729, 12 into 16, 129, 14 into 9, 126, 9 into 36, 324, 5 into 81, 405, 7 into 2, 56, 1792, 4 into 6, 76, 2704. The total of it is 11,456. Here you have to apply in this formula respectively. Then you will be getting the value 12.84. Then illustration 13. In this method, the standard deviation should be calculated for the discrete series. Here height of the students and the number of students representing the height has been given. And for the solution, you have to put into 1, 2, 3, 4, 5, 6 columns. First two columns as it is given in the illustration. Third one should be calculated as deviation. That is deviation taken from the assumed mean. So assumed mean here has been taken as say 162. That is a mid value, a value which is representing in the middle of that should be taken. That is more convenient. Here x minus 162. The values are 157 minus 162 minus 5, 160 minus 162 minus 2, 162 minus 162 0, 164 minus 162 2, 166 minus 162 4, 168 minus 162 6. Then these values should be multiplied. That means 5 into 5, then the minus symbol become positive, thereby 25. Then 2 into 2 4, then 0, 2 into 2 4, 4 into 4 16, 6 into 6 36. Then from this value frequencies corresponding to that should be multiplied. Here 6 into 25, FD, first you calculate the FD. D is in the previous, just before that. 6 into minus 5, minus 30, 7 into minus 2, minus 14, 12 into 0, 0, 10 into 2, 20, 11 into 4, 44, 4 into 6, 24. Then FD square, that is F into 25, that is F into 6 into 25, 150, 7 into 4, 28, 12 into 0, 0, 10 into 4, 40, 11 into 16, 176, 4 into 36, 144. A total of FD to be known, that is sigma FD, that is equal to 44. Then a total of FD square to be taken, that is sigma FD square, equal to 538. Then small sigma equal to sigma FD square by n minus sigma FD by n the whole square, equal to 538 by 50 minus 44 by 50 into the whole square, equal to the value 3.16. Then illustration 14. Here that standard deviation should be calculated for continuous series. That have savings and number of families have been taken into consideration. That may be 100 minus 200, 100 to 200, maybe 1000 or 10,000, usually 1000 to 2000. Monthly saving it is. Like that 100 to 200, 200 to 300, 300 to 400, 400 to 500, 500 to 600. That corresponding the value of frequencies have been given, that is number of families have been given. So for the calculation you have to prepare 1, 2, 3, 4, 5, 6, 7 column table. That first 2 columns are represented with the illustration, and that is X and F. Then first of all, you are in the third column you have to find out the mid value, that is M, that is called mid value being 200 minus 100 by 2, that is 150. 300 minus 200 by 2 equal to 250. Like that you have to calculate, that is 350, 450, 550. In this case it is better to, here that it is direct method. In direct method has been applied. So arithmetic mean should be calculated. So for that you have to calculate the FM. F is 15. 15 into 150, 2000, 250, 20 into 250, 5000, 27 into 350, 9450, 24 into 450, 10,800, 14 into 550, 7,700. Like that you have to calculate. Total of that should be calculated. That seems to be 35,200. Then now calculate that small x, that is M minus x bar, mid value minus x bar. Then in the previous case we should minus x, you have to do x minus x bar. Here it is M minus x bar, that is M mid value. That means 150 minus 352, that is minus 202. 250 minus 352 minus 102. 350 minus 352 minus 2. 450 minus 352, that is 98. 550 minus 352, 198. Then the square of that, this value should be calculated. Minus 202 into minus 202 became plus, that is 40,804. Like that 102 into 102, 10,404. Then 2 into 2, 4. 98 into 98, 9,604. 198 into 198, 39,204. Then Fx square to be calculated. F value should be multiplied with this number. That means 15 into 40,804. 20 into 10,404. 27 into 4, that is 108. 24 into 9,604, that is 2,30,496. Then 14 into 39,204, that is 55,48,856. Total of it should be calculated. There seems to be 15,99,600. Then apply this value in the formula sigma f square, fx small x square minus n. That value gives 126 0.5. Anyway, the calculated value would be in between 100 to 600. If it is going beyond that or below that, means there will be some error in the calculation. Then let us see illustration 15. That is calculation of deviation for the continuous series only. This problem or illustration has been given how to calculate the standard deviation in an easy manner by taking the assumed mean. So here 1, 2, 3, 4, 5, 6, 7 column table should be prepared. First 2 columns to be as like in the problem, then that is in the illustration. Then you have to calculate M value, mid value, that is just like previous one. That is 25 minus 0 by 2, 12.5. 50 minus 20 by 2, that is 37.5. Then 75 minus 50 into 2, 62.5. 100 minus 75 by 2, that is 87.5. Then, sorry, 75 plus you don't take, is 25 by 2, 20 plus 50 by 2, 50 plus 75 by 2, then 100 plus 75 by 2, then 125 plus 100 by 2. Like that it would be calculated. 150 plus 125 by 2. So I have told in the previous case also minus, but it is plus. Thereby you got this value. Then you have to assume some value. So better to assume a value in between. That is, it may be 62.5 or 87.5. And 87.5 has been assumed. Then from this value, that is M 12.5 minus 87.5, that is 75 minus 75. Then 37.5 minus 87.5, that is minus 50. 62.5 minus 87.5, that is minus 25. 87.5 minus 87.5, 0. 112.5 minus 87.5, 25. 137.5 minus 87.5 is 50. Then square of it should be calculated. Then all would become positive value. Minus 75 into minus 75, minus 50 into minus 50, minus 25 into minus 25, that is 620. Then 0. 25 into 25, 50 into 50. Then FD, that is D is in the column 1, 2, 3, fourth column. So minus 75 into 7. Then minus 50 into 11. Then minus 25 into 70. 0 into 14, 0. 25 into 12. 50 into 9. That value has been written in the sixth column. Then total of it should be calculated, that is 750. Then that F should be multiplied with the D square, that is in 1, 2, 3, 4, 5, fifth one, fifth column and second column should be multiplied. That is 7 into 5,625, 11 into 2,500, 17 into 625, 14 into 0, 12 into 625, 9 into 2,500, 22,500. Total of it should be calculated, that is 1,07,500. Total of sigma FD, that is sigma FD, is minus 750. Then applying this value in the formula, it will give 37.5, which is in between 0 to 150. Then illustration 16. Here this illustration has been calculated, given to find out how that is calculated through step deviation method, because that the class interval, that variation is about 50, difference is 50. Thereby it is better to apply by dividing that value by 25, and that accordingly it would be calculated. Then 7 columns here, 1, 2, 3, 4, 5, 6, 7. First 2 columns as it is in the problem. In the third column you should find out that mid value. Mid value can be calculated 50 plus 0 by 2, 25. 100 plus 50 by 2, 75. 150 plus 100 by 2, 125. 200 plus 150 by 2, 175. 250 plus 200 by 2, 225. 300 plus 250 by 2, 275. Then D should be calculated by taking an assumed value. Here assumed value has been taken as 175. because either 125 or 175 should be calculated. If you are taking 175, the largest value will not be there. The smallest value is available in three factors, three variables, and above that only two variables. Then by dividing by 75, that means m minus 175 means 25 minus 175 by 25 minus 6, 75 minus 175 by 25 minus 4, 125 minus 175 by 25 minus 2, 175 minus 175 divided by 25, 0, 225 minus 175 by 25, 2, 275 minus 175 by 2 by 25 is 4. Then square of that should be calculated. That is 6 into 6, 36, 4 into 4, 16, 2 into 2, 4, 2 into 2, 0 into 0, 2 into 2, 4, 4 into 4, 16. Then f value that is in the that column 2 should be multiplied with d dash. D dash is in the fourth column. That means 11 into minus 6, minus 66, 14 into minus 4, minus 56, 19 into minus 2, minus 38, 21 into 0, 0, 17 into 4, 34, 13 into 16, sorry, 13 into 4, 52. Once again I will repeat that FD, that is second column and fourth column only. Thereby 11 into minus 6, 14 into minus 4, 19 into minus 2, 21 into 0, 17 into 2, 13 into 4. Like that we have to apply the d square with the f value, that is in the sixth column. That is 11 into 66. Sorry, 11 d square is in the fifth column. 11 into 36, 396, 14 into 16, 224, 19 into 4, 76, that 21 into 0, 0, 17 into 4, 68, 13 into 16, 208. Then total of these two values should be calculated. The 6th one minus 74 and the sigma FD square is 972. Then apply this value, then you will get the value of 77.5, which is in between 0 to 300. Now let us study about the mathematical properties of standard deviation. The important mathematical properties are: one, combined standard deviation; second one, coefficient of variation; and third one, variance. Combined standard deviation can be calculated through the formula given below. That may be denoted as sigma 1, 2. Combined means there are two standard deviation. How it should be combined to be known. That is n square root of n1 small sigma 1 square plus n2 into small sigma 2 square plus n 3. It would be in 3. Sorry, it would be n1 only. n1 d1 square plus n2 d2 square by n1 plus n2, or small sigma 1 2 equal to, it would be calculated as n1 into small sigma 1 square. That is small sigma 1 standard deviation of that one section of the variable, and plus d1 square. Yes, then n1 into small sigma 1 square plus d1 square plus n2 into small sigma 2 square plus d2 square by n plus n2. Then small sigma 1 2 denotes a combined standard deviation. Sigma 1 means standard deviation of the first group. Sigma 2 means standard deviation of the second group. D1 denotes the difference between the arithmetic mean of the one group with the combined arithmetic mean of the two groups. Then D2 indicates the difference between the arithmetic mean of the second group with the combined arithmetic mean of the two groups. That is sigma, that is x bar 2 minus x bar 1 2. N1 indicates the total number of variables of the first group. N2 indicates the total number of variables of the second group. Combined arithmetic mean can be calculated as sigma a, x bar 1 2 equal to n on x1 bar plus n2 x2 bar by n1 plus n2. That is x bar means arithmetic mean. Then the combined arithmetic mean formula has been given in here. Then illustration 17. Illustration 17 has been given to, as group 1 and 2, number of families in group 1 50, in 2 40, mean income in group 1 2000 and in 2 1000, standard deviation in group 1 195 and in group 2 190. Then calculation of the combined standard deviation, that is x bar 1 2 has been calculated as a n1 x bar 1 plus n2 x bar 2 by n1 plus n2. That value seems to be 1555.6. d1 equal to x bar 1 minus x bar 1 2 equal to 2000 minus 1555.6 equal to 444 plus 4. d2 is x bar 2 minus x bar 1 2 equal to 1000 minus 1555 plus 6, that is minus 555 plus 6. Then combined standard deviation should be calculated as given in the formula, and it is given the value of 521.19. Then illustration 18. In the illustration, 3 classes are given, and in these 3 classes, number of students 90, 60, 50. Mean marks have been given and standard deviation have been given. Here combined standard deviation to be calculated for one as through the formula given. Accordingly, you have to find out the value, and the value seems to be 11.82. Then coefficient of variation. The relative measure of standard deviation is called the coefficient of variation. Standard deviation is only an absolute measure of dispersion. The consistency, uniformity or stability of data cannot be known through the standard deviation. Hence, the coefficient of variation technique is adopted to know whether the data is uniform, consistent, stable and reliable. If the coefficient of variation is greater, then the data are more reliable and be less consistent, less homogeneous, less uniform and less stable. If the value of coefficient of variation varies less, then the character of the data would be less variable and more consistent and more homogeneous and more uniform and more stable. it can be calculated as small sigma by x bar. Then x bar means arithmetic mean. Then it can be denoted in percentage form, means by multiplying 100. Then variance is the square of the standard deviation. Hence variance is the square of standard deviation. It has been given, how it has been calculated. Then relation between standard deviation and other measures of dispersion. There exists a relationship between the standard deviation and quartile deviation, between standard deviation and mean deviation. Of these deviations, quartile deviation is the smallest and standard deviation is the largest one. The mean deviation lies between the standard deviation and the quartile deviation. Quartile deviation is 2 by 3 into small sigma, and mean deviation is 4 by 5 into small sigma. Hence, small sigma equal to 2 by 3 into quartile deviation, or sigma equal to 4 by 5 into mean deviation. Therefore, 3 by 2 quartile deviation equal to 5 by 4 mean deviation equal to 6 by 5 into quartile deviation. The next one is Lorentz curve. That is the fifth one. Lorentz curve is graphic method of measuring dispersion. This method was devised by Max O. Lorentz, a famous economic statistician. It can be drawn by converting the value into percentages. It gives a clear picture about the dispersion of data from the central value. Procedure for drawing Lorentz curve. That is, first to calculate the cumulative value of variables and frequencies. Calculate the cumulative percentage of all variables and frequencies. Then x-axis should be represented with cumulative percentage to variables. Hence, it should be have a scale of 0 to 100. Y-axis should be represented with the cumulative percentage of frequencies. You should also have the scale of 0 to 100. Plot the percentages of cumulative variables against the percentages of corresponding cumulative frequencies. Join all the plotted points to get a curve. Also draw a 45% straight line on the graph in order to know the extent of deviation of variables from the central value. Here the illustration 19, it has been asked to draw a Lorentz curve. marks x, that is x value, number of students F have been given, and that is 10, 40, 50 like that. It would be drawn in a table containing 1, 2, 3, 4, 5, 6 column, and first marks and the second one cumulative marks should be taken. That first marks should be taken, and in the fourth column you can take the number of students. Then 10 mark cumulative marks 10 plus 40, 50, 50 plus 50, 100, 100 plus 60, 160, 160 plus 70, 230, 230 plus 80, 310, 310 plus 90, 400. Then cumulative percentage should be calculated. That means that value is 10 by 400 into 100. 400 is a total value. Like that, 50 by 400 into 100, that is 12.5. 100 by 400 into 12 into 100 equal to 25. And 160 by 400 into 100, 40. 230 by 400 into 100, 57.5. 310 by 400 into, into 100 equal to 77.5. 400 by 400 into 100 is 100. The number of students should be written next to that, and for that cumulative value should be calculated. That is 3. First one to be written 3. Second one 10 plus 3, 13. Fourth, next one 13 plus 14, 27. Then 27 plus 11, 38. 38 plus 6, 44. 44 plus 4, 48. 48 plus 2, 50. Then cumulative value should be calculated as by taking 50 in the denominator. So 3 by 50 into 100, that is 6. 13 by 50 into 100, 26. 27 by 50 into 100, 54. 38 by 50 into 100, 76. 44 by 50 into 100, 88. 48 by 100 into 48 by 50 into 100, 96. 50 by 50 into 100, 100. Then based according to this value, then you can plot the value corresponding to first one 2.5 and 6. For x you have to identify 2.5 and y 6 should be taken. Like that 12.5, for that 26 should be taken. Like that all points should be taken. That is 1, 2, 3, 4, 5, 6, 7 points should be there. So all the points should be drawn out.